Hello, and welcome to Devin's Workshop. Today we will be working on the Adafruit Trinket M0 Neopixel Goggle Kit, and this will be a soldering session. Fit under the camera here, hands. So, with the Goggle Kit you get from Adafruit, you get the goggles, 2 Neopixel rings, an M0 trinket, and some DuPont wire, jumper wire. And this is to bridge between the 2 Neopixels. I would probably prefer, I'm going to probably end up going with hookup wire instead, so get rid of that. And a little battery. And the battery gets plugged into the trinket. And this is a USB 150 milliamp battery. And you recharge it with USB, which I've already recharged it, so should be good to go there. So I'm not sure exactly how I'm going to attack this. I've read the guides, but I want to try and make this an actual wearable project. The way they have it written up on the guide is that it's basically just for costuming, so you're not really supposed to wear it. But I'd like to try and figure out a way where it's actually going to be a wearable. So that's the plan, that's the project. I don't know how long this is going to be. Maybe an hour, maybe 2 hours. I'm not sure. I've never put this together. I have no idea. I will also be going over the code, and we'll be using the example code in CircuitPython, which is kind of a fork of Python and MicroPython, fork of MicroPython really, that runs on microcontrollers. These little guys that have logic and can do LED flashy stuff. It's a lot of fun. So similar to Arduino, except there are a lot of really cool differences that it can do that Arduino can't. But it is a little bit slower because it's an interpreted language that's based on Python. So basically you get Python that runs first, and then MicroPython, and then CircuitPython, which kind of hooks into those two. So it's kind of downstream and runs a little bit slower. Unlike Arduino, which is a compiled language, and that runs really fast, but it also has kind of limitations in some of the cool stuff that it can do, which is why I prefer CircuitPython. CircuitPython is also much, much easier to code. It's ridiculously easy to code. Like, I can do it, so therefore it's got to be easy, because I'm not a very good coder. Okay, so not sure where to start here. I guess I'll describe how we're going to hook this up. So we've got our goggles, and then these go inside the goggles like that, and then we're going to hook wire up, and then the trinket will probably be attached to the right side over here. So we're going to have a wire running from the trinket down into this side. So this will be the in, and then we'll go out from this side to this side. So when we're wiring it up, we need to utilize the out. I don't know what they're really called, port. It's kind of a port, soldering header, pin header, although it's just one pin, so I don't even know what you call that. So that's how we're going to attack it. The distance isn't the best in the world. This is still my kind of first time doing this, so my setup will improve in the future. So let's start getting out some wire. I want to use blue for data, or data if you're a fan of Star Trek. And I'm not sure how long to make this. It's better to, let's see, we're only going from here to here at first, I think. So it doesn't really have to be that long. Okay, so we'll cut it about right there. And these are my big old wire splicers that I usually use for much larger automotive style projects. I still don't have a small one, but this style is really cool. If you've never seen how these guys work, these are really cool. So this side pinches down on the one side of the wire. Oops, sorry. This side pinches down on the one side of the wire as the other side pulls and strips it. And that didn't quite work there. Which is why I have to hold it down, because these don't work so great on small wires. They're meant for like big, thick automotive wires. And this is solid core, so I really don't have to worry about tinning solid core. It's just one piece of wire versus stranded. And there's generally three types of wires. You have solid core, which is one piece of wire. You have stranded, which is a bunch of little strands that come off. Usually they run straight, all in strands. And then there's braided wire, just like girls braid their hair, that's, crisscrossed. So there's solid core, braided, and stranded. And usually for small electronics, you're working with solid core or stranded. There's not a lot of braided wire there. But you do get into braided wire with automotive and grounds. They use braided wire for structural integrity under the car kind of thing. You can tell I come from kind of a car background. So we've got our blue. We'll try to match that up. Cut. Cut. And then I'm going to use green for ground because I'm pretty much out of black. Because isn't black and red really always the colors you run out of first? For exactly that reason. The preference of using black and red for power and ground is it just happens. It happens to everybody. So I'm out of kind of out of black and leaning on the green here. Okay. So now we have our wires, and I have my soldering iron, and I'm intentionally not showing what the temperature is on my Hako, which is a 888D model, because it's not calibrated, and I don't want to give anyone like false impressions about what temperature to set it to. Just set it to whatever temperature your solder melts to and doesn't flash off. Let's see. Let me get out. As long as I'm working on my soldering supplies, these are my usual soldering supplies that I work with. I have Chip Quick, flux in a syringe. So whenever I need to flux something, I squeeze some of that out. Tip tinner, I actually don't use tip tinner anymore. Solder wick to clean up mistakes. And then tweezers if you're working with SMD. We're not going to be working with SMD today. And that's really it. Just basically soldering iron, flux, and wick is pretty much all you need. Okay, and I have a lot of wires here, so I don't want to like burn something accidentally when I get out my soldering iron. Okay, so if we're coming out of the goggle here, we want to go in. So this is going to be data input. So we'll go data input to blue. kind of like that. And what I usually do, you don't have to, but what I usually do is I'll give this little squirt of flux right in there, and that just helps the flux go down into the hole and make a good secure connection. Got my sponge out here, make sure my tip is clean. And oh yeah, you can't really see my soldering setup, so I'll move the goggles out of the way. Don't need those for a little bit anyway. So here's my soldering setup. I have my soldering holder along with my solder on a spool and my sponge. And the sponge is really oversized for this, but I like having a big sponge, so eventually I'm going to modify that to accept a regular size sponge. I don't like how they have these tiny little specialized sponges. Okay. And I don't really need a third hand for something like this. So you just kind of stick it in there. Let's see. Data out is going to be pointing that way. Here's data out, so that's going to be pointing towards the other goggle. And I want to try and route these wires around the ring so that I can still see through the ring. And I'll use super glue to tack this down later. So when we solder this, we want to solder it so that the wires go around. And because there's LEDs on the other side, I don't want to solder from that side. I want to solder from this side. So here's my solder. All right. Come on. Might take a minute here. Get a nice big glob on there, and then boom. Just like that. It's pretty quick. And then later I'll go in and take some dikes. Oh, it's moving. I did a bad job. Might as well hit that other side. Okay, now it's not moving. So that's good. Yeah, so that's how that's done. Might as well. Might as well just cut it now. And try not to cut the LEDs in the process. Oh. There we go. Okay, so that's one down. And let's see. So that's the first one. It's going to go around on the outside. So I guess we will start off with going to the trinket from this side. So the trinket's going to be up on the band, and we need to just start making connections to the trinket, I guess. I'm probably going to use some Velcro to attach the trinket to the band, as well as the battery. I have some large Velcro off camera somewhere that I have to go find. I didn't get that before I started recording because I forgot about it. So let's go with the next one. DC power signal ground, data out. So what's that guy? Ground, power signal ground, power 5 DC. Okay, why is there two V's? I guess that's if you want to feed extra power around the outside. So you got a really long strip, you want to feed it power from both ends, I'm guessing. So at least they tell you exactly which one is the one to start off with. That's my guess. It would be really helpful if I read the guides. I do things my own way. Okay, so this is power, and we said power was going to be the red one? Yeah. Okay, so we got red. And I hit it with a little... Okay, and this one is still going to be kind of like that. So we've got more fluxity flux. Okay, and on this side, just make sure that they're not like contacting one of the LED legs. That would probably mess something up. So when it comes through the other side, just make sure that the pin is only coming up and is soldered around the pinhole. And then power signal ground. And we'll snippity snip. Okay, that's one. And one thing I've learned is when you're dealing with power and ground circuits, you should always twist them. Input data, input ground, so the power and ground are the red and green. And this helps cut down on some kind of interference, although we're not really dealing with RF signals around here, so maybe that'll work, I don't know. But it's got this cute Christmas color, so I'm doing it. Yeah, should be able to see out of that, no problem. Now we just need short wires. Hippity hoppity between the two. How am I going to do that? I guess these little guys, I just don't like the tiny wire size. Just not a fan. Not a fan of the tiny wires. Probably because I'm used to automotive and 12 volts and thick wires for everything. And all this stuff is 3.3 volts for the most part, unless you're dealing with Arduino, which is usually 5 volts. And then sometimes the power supplies, I mean, get regulated down from 9 volts to 5 volts or whatever. Using those cute things named LDOs, whatever those stand for. Low discharge output thingamajiggers. I just call them voltage regulators. It's just easier. Okay, now I have to stick these through the goggle somehow without it looking all kind of janky. Or do these screw off and give me access? That's why they're so tight. Okay, let's just take out the lenses. Yeah, that's one nice thing about these is these just screw right off. Plenty of room. Oh, sorry. Plenty of room in there. Piece of cake. Yeah, I probably should have some kind of music going in the background. And I'm literally just talking to myself because this is not a live stream, this is recording. I am not comfortable with live streaming just yet. My electronic knowledge is noobish. Well, that's very rainbow steampunky, I guess. I'd like to put it into a braid somehow. Maybe the middle. I know I have some heat shrink around here somewhere. Oh, you get to see how I do heat shrink. That's a lot of fun. All right. So here's my Chinese heat shrink thingamajigs. Plenty of choices. I guess we'll go with black. And I need something I can stick all 3 wires through. Okay, that heat shrink is a little long. Need to cut down the heat shrink. Something like that. And we get to go. And now we're going to data out. We can just pull that blue one through. Stick it through. I usually stick it through and then kind of turn it. And I think this one needs to go kind of straight out, so I might have to solder this one in place. Yeah, soldering in place has now become a kind of a fiasco for me since I soldered my S2. Dropped a huge solder blob right on the voltage regulator of the S2. Like a genius. V+, so we're going to go here next. Okay. I don't see any solder on that. There we go. So we got red done, snippers. Don't shoot your eye out when you cut these. At least close your eyes when you do it, because they will fly. You don't want to go to the hospital just because you snipped the end of a wire and ended up getting stuck in your eyeball. I can't see that. I don't think that was good. There, that's good. So, by putting it this way, which the guide shows actually putting it the other way, putting all the wires in from this side, which I was like, I don't understand that at all, but okay. So it seems like this would cause, that would be, so let's say the Adafruit star goes straight up. That would give you like the least amount of wire needed to get from your farthest point and your closest point. Yeah, I think that'll work. Do I want to give it any free play just in case? I'm gonna say yeah, just in case I screw up. So we'll make them a little longer than they have to be. That way I can solder it outside instead of trying to worry about soldering it like right up against the lens, which would be pretty stupid. It's gonna be close. Nope. Nope. I don't have any of those little tiny ones either, so when that happens, you just break out the X-Acto knife. And because this is solid core, X-Acto knives work much better with solid core. You don't have to worry about cutting through the strands, and the core is so thick that it usually is much more forgiving. And if there are any kids out there watching, don't play with X-Acto knives like this. Okay, get your parents to help you, please, because you will cut yourself. These things are ridiculously sharp, and I have a lot of experience doing this. So, yeah, this is one of those get an adult to help you kind of thing. X-Acto knives are not something you want to play with. Even adults shouldn't be playing with X-Acto knives. It's like running with scissors. It's just not. It's not something you want to do unless you absolutely have to. And then we put the X-Acto knife away so it can't roll away and fall off the table and stab us in the leg. Never try to catch a falling X-Acto knife. Because I'm going to have to do some of this soldering like upside down kind of, I'm going to pre-flux all the holes that I need to hit. Power and data input. And if it gets on your skin, don't worry about it. Okay, it's harmless as like soap for your skin. I mean, but eventually wash it off because it does. Like when it dries, it gets sticky as honey. Power signal ground. That's the G. Okay, and now that that is tinned on the top, I can kind of more easily, it gets harder progressively the more wires you add, and you have to kind of intentionally melt the end of the jacket in order to get at the wire. That is going to burn if I touch it. I already know it. Sometimes you just gotta grin and bear it. You gotta heat that sucker up so hot that it melts all the flux, and then you gotta try to push it back in. There. Okay, that's gonna work. Okay, that'll work this way. Also, tiny little sewing needles, great for pinching the end of those wires and then making a turn. And yeah, these were not mine. I did not purchase these. Took these from somebody's sewing kit. Not going to mention who, but she wasn't happy. Again, so any kids watching, yeah, don't take people's tools that don't belong to you. They don't like that. Just FYI. And now we snip. Ka-choo. And if you're not wearing safety glasses, remember, just close your eyes and snip, and you'll be okay. If you find a piece of metal in your hair, later on, don't worry, it'll wash out in the shower. Although metal pieces in the shower drain, I'm not a plumber, don't know. Okay, so that's number 2. And then this goes out to the trinket, which should be on the band, probably about there somewhere. So it'll be like right next to the temple. Well, this will be like right next to the temple. So it'll be a little above the ear, I'm guessing. I'd like to make these longer, but I don't want to go back in and solder all that stuff. So if it comes to it, what I would likely do is just snip these, add another length of wire, and splice them. Add heat shrink. Speaking of heat shrink, now that we're all done with this, I can show you how I usually do heat shrink, but it's probably going to be a bad idea because this is all rubber plastic stuff. But for automotive, I'll show you what I usually do for cars, which in this instance, it's not going to work out very well. I can already tell you that, but I'll show you what I do. Butane torch. Turn the butane torch on. We light the butane torch. Kids, do not do this at home. You keep it very far away because it gets hot, too hot right here. Ow, ow, hot, 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 hot. Okay, so this distance, this far away, will start to melt that heat shrink. And if you get any closer, you're going to start burning plastic. So I'm not going to try that. Okay, so if something starts melting or smoking, okay, that's as much as I want to do. Okay, so that's how I usually deal with heat shrink. Butane torch. That's how car guys do it. Alright, so they're just going into 0. So they got background and pin 0, which is SDA. Now sometimes when you snip these, make sure you're not like snipping the pad off and or snipping the solder right off of it so it's not making a good connection. And I'm going to guess it's USB-C. And I have magnetic tips here from Adafruit, along with magnetic cables. These things are awesome. And I've only got one left. So Adafruit, could you get some more, please? And then I just plug that right into the end. Okay, there we go. Okay, so now it's got a magnetic tip on it, and this is my magnetic cable. Pretty cool stuff. I do not have a default sketch. I haven't even installed the firmware for this, so I guess we're going to go through all that. Moo! Let's go to CircuitPython. Let's see if I can share my Firefox. Yeah, how about that? That's pretty good for a first time. The first thing we want to do is go to circuitpython.org. We'll go to the downloads. We'll type in Trinket, and it is not the Hackspress. It is regular Trinket M0. And I've already tried this on 7.3.3 and 8.0 Beta 2. It did not work. And the reason being, we have to first update the Uf2 Bootloader. So let's download the Updater Uf2. Now I have a special project folder called Adafruit CircuitPython Uf2 Bootloaders, specifically for bootloaders. And as you can see, it's empty because it's the first time I've ever had to update a bootloader. The old bootloader just wasn't working. And this is version 3.14 bootloader for the Trinket M0. So we will save that into the folder. And then we also want to save the 8.0 Beta 2 Uf2. And I also have a section just for 8.0 Beta Uf2s. So this is the Trinket M0. This is basically CircuitPython. Is this one? This Uf2 is CircuitPython for the Trinket. So we'll save that. So now we're on the desktop, and we open up USB. Okay, now on the Trinket, we need to get into bootloader mode, which is 2 quick presses on the reset button. So 1, 2, real quick. And that brings up Trinket Boot. So we'll open Trinket Boot. And now we need to go find our bootloader. So here is the first one we downloaded, which is the Uf2 Bootloader. And then we drag that over to the Trinket. Give that a second. It's uploading the bootloader. Okay, and now if we go back to USB, we'll see it's still in bootloader mode, which is fine. Because the window reloaded, that means it accepted the Uf2 bootloader. Now we need to go and get the Uf2 from 8.0 beta for the Trinket M0 and drag that over. And this is CircuitPython now that we're loading on here. So we updated the bootloader, and then we updated CircuitPython to 8.0 beta. So now, when it reloads, it goes back to the regular CircuitPy drive, which it means that it's running in regular mode. It's been updated, and if we open that up and go to bootout.txt, it should show that we're now running 8.0 beta 2, which happens to be the latest advanced release. And I'm just running that because I'm used to running the advanced releases for beta testing and stuff for CircuitPython. But you can run 7.3.3. Okay, next we go to the CircuitPython code page, which is this page. And as you can see, this is where all of the code is for the example demo. And then right above it, it says download project bundle. And this has got all of the libraries, all of the code, everything that you need in order to run this example. Because this is an official Learn Guide example from Adafruit, so it's got everything that you need all bundled up in one place. So we'll click on Download Project Bundle. And that's going to open up the zip file. Now we need to save the zip file. And I have a folder just for project bundles. So we'll drag that over. Now we can close that. Now this is on the PC. And as you can see, this has got code for CircuitPython 7 or CircuitPython 8 or whatever the latest stable build version is, and the advanced non-stable version. And we're running the advanced version. I'm an advanced user, and I know it works this way, so we're just going to use this. So we go into the project bundle, and it's got the lib folder, which is the library folder. And now we need to open up the USB drive for our CircuitPy device, our Trinket. Although it's not called Trinket, all boards that run CircuitPython, not all boards, but the majority of boards that run CircuitPython are just called CircuitPy USB drive. So we're going to go into the libraries folder, which I've already dragged some of those over earlier. So we'll just copy this, drag that over, replace the files, and now they've got the proper library files in the lib folder. And then we'll go back and we'll just drag the code.py and replace that. Code.py is the thing that auto starts, it auto executes. It's kind of like an auto start file. So when you hit reset, this code automatically runs every time. So this is your running code, and it has to be named code.py. If you name it something else, it's not going to run, because it specifically looks for that file named code.py in order to do its auto start run stuff. So the board has been updated with the new bootloader, updated with the latest beta release of CircuitPython, and it has the code and the libraries and everything that we need on here. And as you can see, it's not working because it does not work on USB power because the pins are to the BAT pin. So this requires battery power. This is why it's important to charge your little battery on USB probably before you begin the project, so that when you get to this step, it's fully charged. And once it's fully charged, there's a tiny little LED, charging LED on here that goes from red, and on this side green when it's fully charged. So I know that this battery is fully charged, and as soon as I plug it in, it should start working. And voila. That's how you put together the Adafruit and Neopixel Goggle kit. If you're using a different microcontroller, you might have to edit the code for the one pinout that the data line is using. So no matter what board you're using, make sure that you get the data pin set in the code correctly, and that should work. And that's all there is to this project. Cool.